where we found mathematics and bowling, and I'm Hannah Marquette.
Spencer.
Okay, so the history of just bowling in general. Okay, so Sir Flinders Petrie, he found primitive bowling balls and pins in a little boy in a little Egyptian boy's grave in 3200 BC. So that it makes it more than 5,200 years old. And then William Hill, right here, this guy, he was a German scientist kind of, and he thought that bowling started in 30 AD in Germany, and they threw stones at sticks called keglers. And kegling is still kind of called bowling in Germany and other parts of America and stuff. But it used to be a religious ceremony in Germany. So German peasants, they carry around these big sticks that were called keglers, and it was for protection kind of. So they just carry them around, and then they'd go to the church, and to prove their faith, they would have to set up their kegler, and they'd have to stand far away. They'd have to throw a stone at it, and if they knocked it down, they were to be deemed sinless, because a lot of people never knocked it down. So that's kind of where that came from. And then King Edward III of England banned bowling in 1366 because his soldiers were preparing for the 100-Year War, and they wouldn't go to archery practice. They just wanted to go bowling, so he banned it so that they'd get better at archery. Okay, and then history of bowling in America. So American bowling, or 10 pins, is kind of like a mixture of German, Dutch, and English influences. So it kind of came from all parts of all parts of the world. But then it was really popular with immigrants, so that's kind of why it was a bunch of different influences. But the first American literature reference to bowling was in Rip Van Winkle, which was in 1819. And the main character, Rip, woke up to the sound of crashing 9 pins. So, and then the first documented actual bowling alley was in New York City, and it's still called the Bowling Green now. And it used to be, they used to lawn bowl, so it was just on grass, and they just bowl there, and they still call it that. And then we don't play 9 pins anymore, we play 10 pins, but back then they played 9 pins, and it was kind of set up like that. So then, they was associated to pubs, tavern, and gambling, so a lot of people get rowdy when they're playing 9 pins, beat up each other up. So then in 1841, a law was passed in Connecticut, and it made it illegal to own a bowling alley. So then people who still wanted to bowl were like, well, why don't we just add a pin? So then they created the 10-pin bowling. So they just added a pin to get past the law. Alright, and then, so since 10-pin bowling was established, we needed to make rules and regulations because it would, the rules would vary from different place to place, and then people would get in fights over it. So then in 1875, the National Bowling Association was started, and then they set a lot of regulations, and they made gambling within bowling illegal and everything. And then later on, they renamed themselves to the American Bowling Congress. And then women were like, well, we want to members too. So then in 1916, the Women's National Bowling Association started, and then they were later renamed to the Women's International Bowling Congress. And then we started the Youth American Bowling Alliance, and that was in 1971, and that's for younger people, and the regulations are a little different. And then all 3 of those joined together to form what we have now, which is the United States Bowling Congress. So that's kind of what, you'll see the symbol on a bunch of leagues and stuff, and they're the ones that set the different standards and everything, and then when the bowling Olympics and stuff like that. Okay, so some of the math we found was Newton's first law, which is the law of inertia. And then so it states that every object in a state of uniform motion tends to remain in that state unless an external force is applied to it. So if something's resting, it's gonna stay at rest until something knocks it down, or if you have something rolling, like bowling ball, it's gonna keep rolling until either friction and gravity stop it, so if it's a long enough length. But then this in bowling, the ball will only completely stop when it hits the back wall, well, unless you bowl it really, really slow, and it'll stop the ball. So that's what we have for that one. And then the history of Newton's first law. Oh, we should do this first. So this is Newton's first law at the bowling alley we went to. Just in place. the history of Newton's first law. This is Descartes. Descartes. He's a French philosopher, and Newton is kind of given credit for this, but in Descartes' Principles of Philosophy, which was published in 1644 when Newton was still a newborn, it says that each thing, as far as in its power, remains in the same state, and that consequently, once it moves, it continues to move. So that's kind of Newton's first law. But then it was actually published as Newton's first law in Isaac Newton's Mathematical Principles of Natural Philosophy, which was published in 1687. So I'm kind of giving credit to Descartes there because he kind of said it first. Okay. So then friction. Friction is really important to bowling because it changes everything on there. So then, when the oil and everything is applied to the lane, the ball doesn't actually roll. It more spins. It slides kind of on there because it's very frictionless. So, the kind of friction involved in bowling is lubricated friction, which means that there's a fluid between the two hard objects. So the bowling ball would be a hard object, and then the fluid, which would be the oil that they put on the lane, and then the hard surface of the lane underneath it. And oil on lane is really important. So it was really cool when we went there. Remember Brittany Burgraff?
Yes.
We had pictures and videos of her bowling.
Oh, okay.
She was working there, and so we explained our assignment to her, and then she took a picture of this machine that they have at Grand River Bowl, and that's the machine that puts the oil on. And
Right. Yeah.
oh, yeah, Bragelman.
Okay.
But so there specifically, it's different in all places, but there at Great River they have oil 41 feet of the lane, so from the foul line to 41 feet away. Then it tapers off at 19 feet, so it's not oiled. And then they just use that kind of like conditioner, it's called. But the absence of oil in the last 19 feet is what causes it to change because the friction changes. So like if you're bowling a hook or anything, which we'll later discuss in this, but so you'll have not a lot of friction, and then at the end it's going to change direction because the friction is going to be different there. So like there's a lot more friction there, so instead of it sliding, it starts to roll and it changes direction and you can angle it around. So that's really important to bowl. And then this is kind of she explained to us. So this is what's on the machine that you saw in the picture. You're like plugging all the different numbers and everything, and it oils it like this. So right here, this is going to be like the most dense, like how much oil they put on there, and then it changes, and then it tapers off there, and there's no oil there. But so that's just how you do it on the machine, and then the machine then just put up the oil and stuff. And yeah, so that was pretty cool.
One thing that she pointed out is that each of these numbers, this is just one little rectangle. So I don't know if you can see it, but there are a bunch of little rectangles right here. You can see them when you go to the bowling alley. You can see little pieces of wood put together, and that's how they determine how dense to make the oil. And so they have to plug it in for each individual rectangle.
Okay, so we have the equation for friction, and so the coefficient of kinetic friction, which is supposed to be bowling, force divided by the product of mass and gravity. So that was our equation for that one, and then we figured out later geometry. And so this is us explaining friction diagrams. Let's down. That one.
Okay, so this is a 12-pound bowling ball, and that converted into mass is 5.45 kilograms. So to find the friction of this ball on that lane, you have to take the force of the bowling ball, which is 4.53, divided by the mass of the bowling ball, which is 5.45, and then times gravity, which is 9.8. So the friction of this bowling ball on that lane, not including the oil, which is on the lane, is 0.0832 newtons.
So we explained it there, and so that's just how much friction is against it. So like if you had like, so if you had a momentum on the flow, you would just track the friction. Okay, the history of friction. So Leonardo da Vinci, he was the first documented philosopher to study friction. I'm sure other people did, but he focused more on machines, and so these are his drawings over here. He focused more on machines and the friction between some different parts and how it affects the productivity of the machines. And then he found the 3 laws of friction, so he focused more on friction than Da Vinci did. He did it with different parts. And he came up with the basic equation of friction that you saw in 1699. It was published, so he came up with that equation. And then Leonard Euler, he's more of a mathematician than anything, but he came up with the theory of different frictions, so static and dynamic frictions. He came up with that, and this date is wrong. It's supposed to be 1707 to 1783. And Philip Bowden and David Moore, in 1950, they kind of broke it down, and they did physical explanations for the law of friction, so they did it how it was more in the real world rather than just mathematical. Okay, so now we have velocity. The equation for velocity is distance divided by time, and so our distance would be 60 feet, which is the length from the power line to the back wall, and then the time involved use your hand to the back and to the time is the back wall of the length of your velocity of the wall.
Alright, so down to business. You guys know that velocity is distance divided by time. So what we're going to do, Haley here is going to time how long it takes this 12-pound ball to exit my hand and touch the back wall. Are you ready? Okay. Here we go.
And then we found the velocity of that, and what we found is that, and we found it was 26 feet per second. And then while we were there, they have a little mile per hour, which is kind of the same thing as velocity in this case, not necessarily in all cases, but. So it's kind of cool to see how fast you're going, and you'll see it on pictures we have later on. Okay, so bowling a hook. So the ball goes in a curving pattern. So you want to hit the pocket, which if you have your first pins and then the 2 next pins, you're gonna have the pocket or the place you want to hit, which is the best place to get a strike is between 1 and 2 if you're right-handed, or 1 and 3 if you're left-handed. So it's that little space in between them. And it's a 6-degree angle with respect to the lane, so it's just 6 degrees over. And then if you wanted to hit this just with a straight on, you have to be standing 6.3 feet to the side, which means that you'd be half into the other people's lane next to you. So you can't really stand there and bowl straight onto the pocket. So people want to bowl with a hook, which is where the ball changes directions right before it hits the pins. So you'll bowl, and then it'll go, and then it'll put the hook in. So it'll change direction at the end, which the friction changes there too. So then, yeah. Okay. Sorry, this is the last day. Ray woman, right? Yep. She was working there, and so then she did Euler. Escher, there we go.
With the one and only Brittany Regal. She is a graduate, 2010. Want to make a shout out to Kruger? Alright, she's going to demonstrate the hook.
So we have a bunch of videos of doing it. So do we want to do? This is one. Oh, that's another ball. Then do we want to do? I think it's this one. This is the one we shoot. Can't really.
All right, bowling ball requirements. There is a league. Haley, yeah. That league has certain requirements in order for you to bowl there. And so for this league, and you have to have a diameter of 8.5 inches, and the weight has to be between 8 to 16. It varies for whether you want a heavier ball, lighter ball, yada yada. We found the volume for a standard bowling ball. So this is a bowling ball with a diameter of 8.5, and that was 321.56 cubic inches, and that was without these holes right here for you to put your fingers in. We found the volume of a ball with the holes. We'll talk about that later. The surface area of this ball, without the little holes, is 226.98 square inches. And that is the formula for the surface area. It's 4 pi radius squared. Alright. So we found the volume of our ball right here. A 12-pound ball with medium-sized finger holdings. And we figured out a formula for it. And so it's the volume of the entire ball, so the volume of this sphere, minus the volume of the two small finger holdings. You can't really see them, but it's where there we go. These two fingers will be put. And then the volume of the thumb hole, because it's slightly bigger. It was actually the radius. What's the diameter? Nope, radius, sorry. The radius of the finger holdings were 2 centimeters, and then the radius of this thumb holding was 2.5. Sorry, this one was 2.5. And then you get the volume of the entire ball with the holes. And that turned out to be 263.29 cubic inches. We found out the volume of the cylinders, which is where you place your fingers, by using this formula to find the cylinder. And also, I found this really interesting. That's how they make the finger holdings. They really have a nice drill. We place different drills into this right here. I don't know if you guys can see it, but that's to drill the holes into the wall. History of volume. Archimedes, he used a lot of different ways to find the area, which helped later on to find the volume. One way was he used the method of exhaustion, and so he took a small, he originally started with the triangle, but he took a small pentagon and he wrapped a bigger circle around that pentagon and wrapped an even bigger pentagon around that circle. And then he found the area, or the amount of space in between the circle and the smaller pentagon and the circle and the bigger pentagon. And then he did that same process with the hexagon, the octagon. He just kept going. He went to decagon. I'm not exactly sure. Might have gone farther. But that's how he found pi, which came to help a lot with finding the volume of the sphere. Also, Egyptians, they used shapes to divide up land after flooding. The Nile would always flood every year or so. And so to divide up the land, take different shapes and sizes to measure how much land the person gets. So this is Archimedes. The bowling ball. Holy cow, I did not realize how complex a bowling ball was. I thought it was just a big ball, heavy ball. But holy cow, it's so complex. Okay, so here we have a cross-section view of the bowling balls. There's two different, mostly, there's only two different kinds of bowling balls. There are symmetric weight block balls and asymmetric weight block balls. And so the outside is made of a mixture of plastic and some other elements, and then the inside is a weight block. And so here, so this right here is symmetric. You can tell symmetric by the pin. And the pin has two purposes. One, so when they're creating the actual ball, it's to hold the plastic coating block in place so it doesn't move. And it also divides the weight block as a line of symmetry, basically. Here is an asymmetric weight block. And as you can see, it's not symmetric. It juts out right here. It's has a right angle right there. That totally determines, well, they both act about the same, but with this ball, you can tweak it a little bit. It depends on the person, really, and what they like. Okay, just 1 second here. And then there's 2 lines of symmetry almost. They won't be exactly, but these 2 divide to the best of the ability of the line of symmetry. You want to go to that side. There we go. So here, we leave this one. Yeah. So this is the pin. That's the green little dot there, and then this is the other pin, PSA. And so that's what it looks like on a normal ball. Okay, so here we have, this is ball, and the CG stands for the intersection point of the ball's surface and the center of gravity, and that's on the outside of the ball. And then W sub 0, that is the initial rotation speed. So when you release the ball from your hand and how you spin it, the greater the rotation speed, the bigger the hook will be. And then the positive axis point is the initial axis of rotation, so that axis that you rotate the ball. So as the ball travels down the lane, it will spin and it'll wobble a little bit. So it's kind of hard to see. I've been looking at this for a week, so I can see it. But imagine with me, we're looking down the lane, and sorry guys, you're looking down the lane, and so these lines right here, they're the track flares. It's a little bit off. The track flares is the lines that eventually form on the ball. It's made of the oils, so the oils that come off of the track, the lane, there we go. They come off of the lane onto the ball, and it'll make these track flares. So it'll be spinning like that, and then it'll also be wobbling, and it'll have a curve that you put on. It's like a 3D deal. And the precession is the change in direction over time. That all depends on how much spin you put on the ball. And here you have, this is kind of a graph almost of what it all looks like put together. And so the y-axis is the foul line, the x-axis is the gutter, and the z-axis right here is vertical axis. And let's see. Okay, so as I said earlier, the W sub 0 is how much spin you put on the ball. And V sub 0, we all know, is the initial velocity that when you release the ball, that initial velocity. And Haley mentioned earlier that the first 41 feet, the ball just slides. It's so oiled down that it actually doesn't roll that much. It just keeps spinning, and just slides along the lane until it reaches the 41 feet, and then the next 19 feet have no oil whatsoever, and that's where the hook comes into handy. The more the ball spins, for the first 41 feet, 41 feet, the more friction it'll develop when it hits that 19 feet left area, and that'll create bigger hook motion. That's what this symbol stands for, and it's going to try to reach this pocket, and the pocket is for right-handers 1 and 3, right? 1 and 2. Lefties it's 1 and 3. That is right in between those two. So the more you can get it into that pocket, the likelihood of you getting a strike is much better.
I used to be afraid of my stairs. I was living in half my house.
The PDA presents how to bowl like a hose. Step 1, practice precise footwork. Step 2, maintain proper bowling posture. Step 3, always follow through. And remember, keep your composure. For more the PBA Tour on ESPN.
So that was a little commercial put out by that company to get people out there and have some fun.
You're watching America This Morning, America's #1 early morning news.
Okay, believe it or not, the bowler you're about to see is a professional.
Starting to figure things out, Vegan lurking. Oh my goodness gracious! From bad to worse.
Oh, wow, that is just humiliating. Josh Blanchard was taking part in the World Championship qualifier in Las Vegas when the ball got stuck to his fingers. Yeah, we got a test. We could tell.
Yeah, he wobbled onto the alley where, as you see, he slipped and fell. Ooh, amazingly, no one in the audience laughed. I guess because we weren't there. But Blanchard isn't likely to live this one down anytime soon. He'll probably show up on blooper reels for some time to come. Ooh, bowling was so dangerous.
Then scoring. Scoring is really pretty simple. There are 10 frames, and the maximum score you can get. Sorry, the maximum score you can get is 300. And the strike, so you take the 10. Well, first off, the strike is when you hit all the pins in one roll, and so that's when you take the 10 pins that you roll down. That's 27. Sorry, the 10 pins that you knock down in that roll, and plus the value of the next 2 rolls. So the best roll that you could get is 30 pins, so you take the initial 10 that you knock down, and then let's say you get a strike for the next 2 rolls, and then those additional 20 points. A spare occurs when you knock down all 10 of the pins except in one frame, so it takes you 2 rolls to do that, and that's when you take the initial 10 knockdown plus the value of the next roll, so your best score would be 20 pins. And then the open frame occurs when you don't knock down all 10 pins in one frame, so that's when you just add up the amount of pins you knock down total. Pretty simple. This is what it'll look like on the screen. Just for the record, I did win. Okay. Yeah. GoPros.
And then this was just like this statistic sheet they gave us at the end. And so it'll just like tell you like what you all hold and everything, and then it'll tell you like the percentiles and stuff of like what percent you're gonna get gutter balls and stuff, and like I had 4 to 21% that I did gutter ball.